Today let's start with a quick warm-up. Why don't you go ahead and pause the video and then just try each of these problems on your own and then check your work. On our first one we have 2 plus 3 times 8 when I substitute in my values. Remember, order of operations I have to multiply first, so this is the same as 2 plus 24, which gives us 26. On our second one we have to do 2 times -3, and then we're subtracting 8, which is the same as -6 minus 8, which gives us a final answer of -14. On our third one we have 1/2 times 8 plus -3, which is the same as 4 plus -3, or just 1. On number 4 we have 4 times 8 minus -3, which is the same as 32 minus -3, or plus a positive, which gives us 35. And then on our last one we have -3 to the second power plus 8, which is going to give us 9 plus 8, which is 17. Now your warm-up today directly relates into what our goal is for today, which is to identify independent and dependent variables, but mostly it's being able to write an equation in function notation and then evaluate it. Alright, so we're going to start by determining the relationship between the x and y values, and we're going to try to write an equation for it. So here's a relation. We have 1, 3, 2, 6, 3, 9, and 4, 12. So I'm going to go ahead and just fill those values in and make a table. So 1, 3, 2, 6, 3, 9, and 4, 12. So for step 1, we want to list possible relationships that you see between the first x and y values. So to get from 1 to 3, I could have 3 times x, or I could have x plus 2. Those are the possible relationships we see between x and y. Now we use that to determine which relationship works for the other x and y values. So if you looked, if we continued on the table, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Or we'd have 2 plus 2, but that would not equal 6, 3 plus 2 does not equal 9, and 4 plus 2 does not equal 12. So in other words, that adding 2 is not the relationship. So the value of y is 3 times x. Or to write that in an equation is y equals 3x. The main thing to remember is that the input of a function is the independent variable, and the output of a function is the dependent variable. And typically this is going to be our x value, and typically this is going to be our y value. And the value of the output variable depends on, or is a function of, the value of the independent variable. Now what this relates to is the fact that an algebraic expression that defines a function is a function rule. The dependent variable is a function of the independent variable. Or in other words, because remember our dependent variable is typically y and our independent variable is typically x, y is a function of x, or we could say y is f of x because we abbreviate with function of x. So y is the same thing as f of x, and this is what we use for function notation. And the reason we do that is as you get into higher math, you start seeing multiple graphs, multiple things graphed on the same coordinate plane. and they can use different variables instead of f to name the different functions. Now there's been a lot of vocab in the last lesson and then this lesson, so just remember there are several different ways to describe the variables of a function. So your independent variable could be an x value, whereas your dependent variable would be your y value. Another way to say it is domain is your independent and range is your dependent, or input is your independent and output is our dependent, or our independent is just x and then our dependent would be f of x. So for practice, we are going to read through some situations and identify the independent and dependent variables of the situation. So in our first problem, a painter must measure a room before deciding how much paint to buy. So in other words, the amount of paint depends on the size of the room. Okay, so your dependent is going to be the amount of paint, and the independent is going to be the size of the room. So why don't you pause the video and then try this one on your own. A veterinarian must weigh an animal before determining the amount of medication. So the medication depends on the weight. So the dependent is going to be the medication and the independent is going to be the weight. Now we'll look at how this relates to writing function rules. So what we're going to do is identify the independent and dependent variables, but then we're going to use that information to actually write a function rule or equation. So here a math tutor charges $35 per hour. So the amount of math tutor charges depends on the number of hours. So your dependent variable is going to be the amount charged.
I bet you can't find me.
And the independent is going to be the number of hours. Now we look at how those two are related. So we're going to let h represent the number of hours of tutoring. So the function or the amount of math tutor charges is basically the cost, or the f of h is equal to $35 times h, because it's $35 per hour. So now let's look at another situation. Here a fitness center charges a $100 initiation fee plus $40 per month. So our dependent is going to be the amount charged and the independent is going to be the number of months. Okay, so now I'm going to pick m to represent the number of months. So the function for the amount the fitness charger charges is the function of m is equal to the $100 that they just pay once plus the $40 per month, so times m. Now I want you to pause the video and try this one out on your own, and then you can check your work. So here an amusement park charges a $6 parking fee plus $29.99 per person. So your dependent, once again, is going to be your charge, and your independent is going to be the number of people. Here I'm going to let C represent, or here x, sorry, represent the number of people or persons in the car. So the function of x is going to equal the $6 just to park the car plus the $29.99 per person, so times x. Now the thing is once we have these function rules, we can actually evaluate for different values or different input values to find other points on our function. So here, for when f of x is equal to 3x plus 2, we want to find when f of x when x is equal to 7 and when x is equal to negative 4. So what we're going to do is basically this becomes f of 7, and every time we see x in our function, we're going to go ahead and replace it with that 7. So here this becomes 3 times 7 plus 2. Now a lot of people get confused with this part over here. With the fact that 7 got put in there, we actually just leave that. It's kind of like our y. We're just going to leave it there. That function of 7 is going to equal 3 times 7, which is 21, plus 2. So f of 7 is equal to 23. So 23 would be our output value and 7 is our input value. So why don't you try the next one for you when your x is negative 4. So now we're looking for f of negative 4 is equal to 3 times negative 4 plus 2. So f of negative 4 is equal to negative 12 plus 2, because we have to multiply first. So lastly, f of negative 4 is equal to negative 10. So why don't you pause the video and try these next two on your own. So now we're finding the h of r. So like I said earlier, it's not always f of x or anything like that. This time it's still function notation. Now we're just using h and we're using r. So here we're finding the function or h of this function when r is 600. So we're going to do 1/3 times 600 plus 2. So 1/3 of 600 is going to be 200 plus 2. So h of 600 is going to be 202. Oops, not 2002. Alright, so now we're going to find the same thing, but we're going to find h of negative 12 equals 1/3 times negative 12 plus 2. And this becomes negative 4 plus 2. So h of negative 12 is equal to negative 2. One thing to keep in mind is even though technically we can put any value for a domain, it doesn't always necessarily work, especially when we're talking about real world situations. Sometimes it just doesn't work out that your answers would be reasonable. So for example, a number representing the length of an object cannot be negative, and only whole numbers can represent a number of people because we can't have like 1.5 people. So you just have to keep that in mind when we're looking at our domain and range. So here we want to write a function rule to describe the number of watts used for each setting, and we're going to find a reasonable domain and range for this function. So the settings on a space heater are the whole numbers from 0 to 3. The total watts used for each setting is 500 times the setting number. So in other words, for each setting, the number of watts is f of x equals 500 times x watts. So here, if 0 was our x, then our f of x would be 500 times 0, which is also just 0. 500 times 1, which would be 500. 500 times 2, which would be 1,000. And then 500 times 3, which would be 1,500. So here, because it says the settings are for whole numbers, we can't have any fractions. So our domain would just be the set 0, 1, 2, and 3. And then our range would be 0, 500, 1,000, and 1,500.
But why can't we draw on there?
So if you have any questions, let me know. Otherwise, you can get started on your homework.